I'm going to try a new way of teaching you. Yes. Okay, class. Look. Next. Okay. Memorize.
Oh wait, this is identity.
These are also they also can be considered identities. Whatever you put on the left hand side, right hand side, they'll be the same. Okay? So if you turn to page 280, you have 4 more to go.
What? 4 more identities.
Yeah, these are 1, 2, there are 4 more. Okay, let's take a look at page 280 first.
Okay, next page.
Okay?
Oh, this one.
Now,
Oh, okay,
wait. You see what I want you to see already at page 280 at the top, there are 6 of them. You need to know all of them, you need to memorize. Let's go down to the bottom of the page. It says, word example number 6, question B. Sine 37 degrees, cosine 23 degrees, plus cosine 37 degrees, sine 23 degrees. You are supposed to evaluate this without using a calculator. Based on what I have up here, do you know what to do?
Sine A plus B.
Okay, so this is equal to sine 37 plus 23 degrees, which is 60 degrees. Okay, sine 60 degrees, how much is that? Is it half? Is it half? Square root 3 over 2. Easy or not? Okay, wait. If I give you the formula, then this is the question. Are you able to do this by yourself?
Yes.
Okay, are you able to apply the formula to arrive at the answer?
Yes.
Can, right? Okay. Is there any difference in this approach and what I've always done?
Yes.
What's the difference?
You always derive first.
I always derive. This time I never derive. I give you formula, now use and do. It can work. Do you prefer this or do you want me to derive?
Derive.
Who wants to derive? Who is comfortable with just don't talk so much, give me formula, I do can already. Because yeah, some people are really okay with that. They put their hands. So for the benefit of the majority, I will derive. But for those of you who are comfortable with using the formula right, go ahead and work out the rest out already.
So how long does it take to derive this?
5 minutes.
I answer that kind of thing.
We have time lah.
But you need time consuming, so I wouldn't do that.
You don't have to derive it in an exam. It's just that when at the end of the day, when you graduate, right, at least you can look at this and say, once upon a time I knew how to derive it. It is not just a bunch of numbers added up to give me a relationship. Okay, I'm going to go according to what your textbook has, because that's the most elegant way of deriving it, I feel. Okay, how many right angle triangles do you see? 2 right angle triangles, okay? The first thing that we want to find is what is sine A plus B? We want to answer this question. Do you see the angle A plus B? Can I? Okay. We are going to approach this using area of triangle. What is the area of this big triangle? You see 3 triangles, right? What's the area of the big triangle? Of PQR is half. Okay, PQ which is R lah. Then the other side, P and sine A plus B. Okay, So you see I got my sine A plus B appearing already. I've got two other triangles, right? What is the area of a smaller triangle? Area of triangle PQS, for example. Half. Small letters, what is it? H. P meh? PQS. This one, half H and R. Sine A. Right? Okay, what about the other triangle? Half P H sine B. What is the relationship between these three expressions?
Area of PQS and SQR add up to area of
It's an addition, right? So the bottom two add together must give me the third one, right? Because area is fixed in this case. Let's write them out. Half PH sine B plus half HR sine A is half RP sine A plus B. Okay, what can we do first? What's the first thing we can do? Times half, then you get 1/4. Times 2, okay, let's remove all of them. Okay, next. What can we do? Divide. If I divide by H, yeah, the H will disappear, but there'll be an over H over here. You want to put over H first, is it? You divide by sine B, then here also divide by sine B, here divide by sine B. Okay, wait, you think about it. What is it that you want, Sine A plus B, right? So what should we divide by? Divide by RP. Okay? We divide by RP. Okay, now I'm going to switch the place because I want the sine A plus B on the left hand side. So sine A plus B. And on the other side, when I divide by RP, what do I have?
H over R.
H over R, sine B. Okay, next plus, when I divide this by RP.
H over P.
Okay, next, what is H over R in the diagram? H over R. It's a ratio, right? What exactly is this ratio? This H over R. Cosine? Is it cosine? Cosine what? Cosine A. Adjacent over hypotenuse. Okay, this is cosine A. Okay, next. H over P. H over P, what's that? Cosine. B sine A. Proven. Quite fun, right? No. But do we need to be able to derive this in exam? No, you don't need to. For April, if you choose to memorize, can apply can already. But at least you have confidence in what you're doing now. So what about the case of sine, for example, A plus, watch this. Watch. Sine A minus B. By the way, don't need to copy down, it's all in your textbook. What about sine A minus B? Do you want to draw triangles all over again? Yes. No need. We have already proven this. We're all convinced. These two are the same. Okay?
So we do letter equal by here now.
Wait. How do we go from... What's the difference between these two?
Only the sign.
Sine open bracket same, right? A also same, right? But it's just that the B became a minus B. If I replace every time I see the B, replace it with minus B, will it still be true? Think about the question. If I replace all the B's over here, I change this B to become minus B. I change this out minus B, change this out minus B. Will it still be true? Yes or no? Yes or no? Yes, it will be, because we have already proven that regardless of the values of A or B, whatever you like, don't care. As long as you're consistent in the right hand side, it will be true. Just like earlier in our identities, right? We anyhow put it at 10 degrees. It was true. Left hand side equal right hand side. You put 5 degrees, it will still be true. In this case, if you change your B to become minus B, which I agree it may be confusing. So to help you a bit, let's change it to minus C. Let's change this to A minus C. Okay, so do want B versus minus B. We change B to become minus C. Okay, so in this case, we let B be equals to negative C. This one you can accept? Yes. Can, Okay, so we have cosine A sine negative C plus cosine negative C sine A, right? Okay. Now, tell me, what is the relationship between sine negative C versus sine C? Is there a relationship? What is the relationship? They are equal. Don't believe? Use your calculator and press. We have gone through this before. They are equal. Okay? So this is the same as sine C. Okay? And next, plus cosine negative C. Okay, now let's change this to cosine versus cosine C. What is the relationship? There is a negative, yes. So this is the same as plus a negative cosine C sine A. Okay? So next, this is the same as cosine A sine C minus cosine C sine A. This is the next relationship we have, A minus C. Okay? But, we start out with A and B. Then you look at page 280, the top, the 6 formulas over there. It is all sine A plus B, sine A minus B. Cosine A plus B, cosine A minus B. Tangent A plus B, tangent A minus B. Are you sure you want to introduce a C over here? Not a good idea. Let's change out the C back to B. Okay? Just change only because C is just a letter one. I can change it to B if I like. All this become B. Okay, and we forget about all this. That's why I'm going to cancel it now. Sine C equals sine negative C, yes, correct. Wait, no. Did I say that? Oh no, opposite. No. Oh no, I made a mistake. Sine C equals to negative sine C. Cosine C equals to cosine negative C. Okay. So early on. Oh no. Okay, wait. Let me rectify it. Here there's a negative.
Rectify some in between.
Yeah. Sine C. And then this is okay. I've rectified it already. No, they are not the same. Okay, I've rectified it already. Sine negative C is the same as negative sine C. Cosine negative C is the same as cosine C. Am I right? Am I? Correct lah. Okay, so here we have negative cosine A sine C plus sine A cosine C. Okay, which is the same as sine A cosine C minus sine C cosine A. Okay, class. Now at this point, I will change all the B to become all the C to become B already. So next, sine A minus B, sine A cosine B minus sine B cosine A. Cosine A. Yeah, can. Okay, after talking so much, right? I hope you don't feel that we wasted our time because I'm confused. Because it can be done. All the 6 formula that I told you on page 280, I'm now going to combine them into 3. And watch this, sine A plus minus B equals to sine A cosine B plus minus cosine A. I'll follow the textbook. Sine B. Okay, I have combined the first two formula into this one. What this means is that on your side, if it is a plus, it will be a plus. If it is a minus, then the other side must be simple. Okay, next. Cosine. Now watch this. This is not in your textbook. This will be sine A cosine B. Okay. Now I have combined the third and fourth one into this formula. What do you notice? So you see there's a change in the sign. There is a change in the sign. And the last one? Tangent A plus minus B is tangent A plus minus tangent B over 1. Okay, these are the three. Homework. Practice now 6. A, B, C. Refer, don't have B lah. Refer to the work example 6. We have already done one of them. Okay?
So,
Yes.
how come then suddenly from this topic, right, became memorize this entire block now?